Pedigrees. These are a chart used to track traits through generations, much like a family tree. What you will notice is you will have shaded individuals and unshaded individuals. Now, as you look at the diagram below, or the pedigree, there is a key that shows you males, females. Males are squares, females are circles. Most pedigrees will not come with this key. You will need to memorize that males are squares, females are circles, and affected individuals are shaded. Usually we are working with a recessive trait and disease. However, if this is not the norm, we will give you some information to help you with that. Generations are given Roman numerals, and individuals and generations are given numbers. A couple of other things in case you've never seen a pedigree. These are two individuals who have produced these offspring. These individuals have produced twins here and another child here. I just wanted to make sure that we can follow this diagram. Why do we number pedigrees? This will allow us to reference individuals both in questions and our answers. So the question then is, how do we number these individuals? You will always give each generation, or row if you will, a Roman numeral. Then within each generation you will number them. 1, 2, we start over, 1, 2, 3, 4, 1, 2, 3. This allows me to say individual 2, 3 is affected, or is individual 2, 1 affected? And your answer would be no. Within pedigree problems, we'll also combine what you have learned prior. You'll notice here we are dealing with complete dominance, where normal vision is capital N, night blindness is little n. The generations and individuals have already been numbered for you, but if they hadn't, that would have been our first step. The next step is, I like to fill in my recessive individuals. I will show you why this is a very helpful hint in a little bit. Right now, please fill in your recessive individuals. What is nice about filling in these recessive individuals, remember, this is a child coming from these parents, which means this recessive individual, 2, 1, received a little allele from both dad and mom. You'll notice the other offspring are not affected, which means, and as well as dad is not affected. We know here these children must be heterozygous because they would have gotten an affected allele or recessive allele from mom. Over here, we know these individuals are capital N for sure. This individual is a capital N. This individual is a capital N. This one must have a capital N. This one, this one, this one. Now, when we get to our child here, who's also recessive, we know that a little allele must have again comes from dad. Over here, this individual must be heterozygous, an unaffected allele from dad, and a recessive allele from mom. Working backwards here, this parent is unaffected, mom, with a capital N, and must have a little n because 3 children are affected, making this child big N, little n. Over here, we know this parent must have a capital N in order for this child to be unaffected. And the other allele must be a little n because they did have a child who is affected with night blindness, and a little n must come from both mom and dad. There's a capital. They're heterozygous. I'm going to use an eraser just to clean that up. capital N, little n. This child here is unaffected. They must have gotten the capital N from dad, which means their other allele is a little n from mom, or recessive. We know these are also capital N. But without more information, it is hard to know for sure what the other alleles are. If individuals 2,2 and 2,8, so we're going to look at 2,2, which is this individual here, and 2,8, which is this individual here, marry and have children, what are the possible genotypes of any of the children they might have? 2,2 is big N, little n. 2,8 is little n, or heterozygous and homozygous recessive. The possible genotypes are half heterozygous and half homozygous recessive. This problem is not labeled or numbered, so that is our first step. Before we even read the problem, we're going to number our generations, 1 and 2. Now we'll number our individuals, 1, 2, 1, 2, 3, 4. Now let's look at these questions as a series of questions. Number 1, could this trait be inherited as a simple autosomal recessive? Which would mean B would be your normal state, little b would be the shaded or recessive trait that they've inherited. If we look at this, remember, we're going to label first our children. This one clearly would have to be little b, which would make this parent big B, little b, and this parent big B, little b. Why? Because each allele needs to come from the parent. And if we cross big B, little b, with big B, little b, for those of you who are not able to look at this in your head, we can still use Punnett squares. You'll notice we do get 1 affected child and 3 non-affected children. I'm sorry for that interruption. Again, you'll notice we have 1 child who does carry, who would be our shaded individual, and 3 who are not affected, as we see. So could this trait be inherited as a simple autosomal recessive? Yes, it's a possibility. Now I'm going to erase those so that I can answer my next question. Number 2. Could this trait be inherited as a simple autosomal dominant? This would mean capital B is shaded, little b would be unshaded, or what I'm calling normal here. As you can see, you should be able to recognize right off the bat that this is not a possibility. And the reason is, if this trait were an autosomal dominant, one of the parents should have been shaded in, but neither is shaded in, which means they cannot produce a child. Both parents are homozygous, recessive, normal, or unshaded, if you will, showing that, again, they could not produce this individual 2-1, which means this is not a possibility. Again, let's erase so we can look at number 3. Could this trait be inherited as a simple sex-linked recessive trait? Now we'll change our key from problem 1. XB would be normal or unshaded, if you will. X little b would be the shaded individual. That would mean dad would be X capital BY because he is not shaded. Mom would be X capital B, X little b. And the reason I know this is this child here is X little b Y. Now if we do a cross to test this theory, we get X big B, X big B, X big B Y, X big B, X little b, X little b Y. Notice this is our shaded individual here. XBY is our individual here. And then these two individuals are here and here. This cross results in an almost perfect match for us. So yes, this is a possibility that this is a sex-linked recessive trait. If they then asked me, which one do I think this is most likely out of these three possibilities, I would think number 3 is our best possibility because the results match absolutely perfectly with the gender. Now, 1 or 3 are possibilities, but again, I'm picking number 3 because number 3 matches even better with the gender than number 1. I hope this has helped you with pedigree problems. Remember, number your generations with Roman numerals, number your individuals 1 through however many you need, and always fill in the genotypes of your recessive people first. Work backwards to figure out the parents. Yes, there may be cases where you do not know the second allele of the parents, and that is okay. If you have any further questions, please let me know.